Rigid body physics is used to simulate solid objects that don't squish or deform on impact. You can add rigid body physics to any mesh object in the physics panel. Just make sure your object is selected, and then click Enable Rigid Body. Once you do that, and if we play back our animation, you can see Suzanne is falling, and she will continue to fall due to gravity. Now, maybe we want her to collide with this plane. And for most other physics types, we would make this plane be a collision object. But in Blender, rigid bodies can only interact with other rigid bodies and force fields. So let's make this plane a rigid body. Now, as you might imagine, if we play this back, they're both going to fall, but that's because they're both active. If we change the plane from active to be a passive type, that just means that no matter what forces or gravity or other rigid bodies you throw at it, it's always going to stay in the same place and not budge. So now if we play back our animation, we have Suzanne nicely falling on the ground. Now let's go back to Suzanne and take a look at some of these other options that we have. Under Type, we have two checkboxes. The first enables dynamics. If we uncheck this, it won't be included in the simulation, meaning it won't collide with anything and it won't fall down due to gravity. If we play this back, absolutely nothing is happening, just like you would expect. Animated determines whether or not we're actually using this simulation data to move the object. If we check this, it'll use the animation data instead. So let's give Suzanne a really short animation. Let's say on frame 1, she's just sitting over here on the side. I'll click I in the viewport to insert a location keyframe. And then on frame 10, let's move her a little bit over to the side and up a little bit. Press I to insert another location keyframe. So if we play back our animation, she's just going to fall on the floor like we would expect with a rigid body and won't follow that animation at all. However, if we check animated, then she'll use that animation, she'll still collide with things, but it doesn't really look that good because she's not using any of the dynamics. At that point, she may as well be passive. But the reason this is really helpful is because we can animate both of these checkboxes. So for animated, on frame 10, let's uncheck this and press I while hovering over the checkbox. And that's going to insert a keyframe. If we go back one frame to frame 9, check the box, and hit I again to insert another keyframe, then before frame 9, she's going to be animated, but then after frame 10 and after, she's going to be dynamic. So now when we play this back, it's essentially as if we're launching Suzanne. So those two checkboxes definitely come in handy. Now that we have Suzanne being launched, let's add something for her to collide with. For that, I'm just going to Shift A, add a mesh and a cube, pull that up, and I'm going to duplicate that 2 more times. Shift D, Z, pull that up. Now a quick way to add rigid bodies to a scene is just to select everything you want to be a rigid body. In the Physics tab of the toolbar, click Add Active. Now when we do that, it'll do all the work for us, and now we have a couple other active rigid bodies. Awesome. Now the last thing I want to talk about in this video is mass. And since we have gravity, that's just how heavy the object is. So if we click on Suzanne and make her a little bit heavier, say have a mass of 10, then she's going to fly through these boxes as if they're not quite as heavy, because she's going to have a lot more momentum from being thrown. So we could play with this quite a bit, but the last thing I want to show you is how to get the mass of real-world objects and apply them to our scene. So for instance, say we want to have a technical simulation that's very, very accurate. What we could do is, with our Suzanne object selected, we could go to the toolbar and click Calculate Mass. And that's going to bring up this list of lots of real-world objects that we can then apply the mass of to our object based on our object's dimensions. So for Suzanne, let's make her be, say, concrete. And if we play this back, she's going to blow through those cubes like they're nothing. But if we select our cubes, go to Calculate Mass, and we have these be, let's make them solid gold. Then if we play this back, then she's definitely not going to be able to go through them. So if you want your simulations to be a little bit more accurate, you can use that Calculate Mass. Otherwise, just eyeballing it generally works. So that's the basics of rigid body simulations. In the next couple videos, we're going to be looking at a few more of the options so that you can have a little bit more control of more complex simulations.